Hi, this is Lucy Sullivan interviewing John Ives on June 6, 2012. Okay, John, when and where did you receive your degree, and where do you currently work?
Okay, I got my Bachelor of Science Mechanical Engineering degree at Queen's University, which is in Kingston, Ontario, Canada. That was in 1968. And I'm currently sort of semi-retired, but I'm an adjunct professor at the University of Western Ontario, which is in London, Ontario, Canada. And then I'm a R&D engineer at Ives EEG Solutions in Newburyport, Massachusetts.
What drew you to EEG and diagnostics?
I guess it was my first job coming out of a postdoc study, and that was at the Montreal Neurological Institute in Montreal. And I started working for Dr. Glure and Dr. Rasmussen. And that was my really first exposure to EEG, and that was in 1970.
Was it a popular specialty when you were starting your career?
Sorry, I missed that question.
Was it a popular specialty when you started?
Oh. Okay, that was what I was looking at then was, since I was a mechanical engineer, I was looking at artificial heart and artificial limbs. So I was looking in a totally different direction that I ended up in.
Who were your early mentors?
Well, it was really Dr. Pierre Glure and Dr. Ted Rasmussen and I guess Dr. Herbert Jasper at that time. And I guess since I was in the House of Penfield, that was another influence, certainly.
And what were your earliest career influences?
I guess it was, I got exposed to EEG right away in that respect. And I just got started on projects in the area of EEG and epilepsy. So that's how I got started into that.
If you hadn't become an engineer and inventor, what would you have liked to have done?
I probably would have ended up in industry, I guess. Being a mechanical engineer, it's fairly general, so if I hadn't had the opportunity at the Montreal Neurological Institute, I probably would have gone into some industrial area.
Why do you think the field took off when and how it did?
Well, I was in the right place at the right time, I guess. The Dr. Glure and another researcher, Doug Skuse, had just installed a digital computer, a PDP-12 computer at the MNI to aid in the area of neurophysiology. And I arrived at the same time that computer did, as well as another computer engineer that was I guess in about January, March of 1970. And
what equipment did you train on, and what were the main limitations of it?
Well, the main computer at that time was the digital PDP-12. It was quite large. It filled the wall of a small room, and it was not really portable at all, and it had very small memory and not very fast. The EEG machines that I was exposed to at that time were the Siemens Mingograph. That was expensive, but very high quality EEG. And then the Graphs Model 8. Both of these were 16-channel machines, so they just started to get into 16-channel EEG As prior to that, it was only 8 channels.
What other equipment have you used over the years, and what are the pros and cons of them?
Well, we ended up not finding very much in industry that we could get a hold of, so we mainly ended up developing our own equipment to meet the needs of small preamplifiers and data acquisition systems that were specifically designed for EEG. And so this was really, we got into ambulatory EEG and then cable telemetry with head-mounted preamps and developing home computers and special electrodes. So we really did not get much from industry. We had to just really build from almost scratch our own equipment.
And what gave you the idea to, and I thought it was interesting, to put the amplifiers actually on the head?
Well, we were able to make them small enough that they could go there, and that reduced the distance between the electrode and the amplifier, so therefore it eliminated a lot of artifact that could get in there from long leads. And then this eliminated the relative movement of the EEG source and the amplifier. So it significantly increased the quality of the EEG obtained. And we could get EEG off ambulatory patients. They didn't have to be in a bed, and they no longer had to be in a shielded room.
What are the main ways in which the field has changed over your career?
I guess everything when I came in was ink and pen and galvanometers and paper. So the digital computers allowed us to move away from that into specialty computers, special software, small electronics, and special electrodes. So all that combined to significantly change the way EEG was performed at that time.
How has scientific knowledge changed the field, and what do you think were the big breakthroughs?
I guess we now have a better knowledge of the seizure focus. As before 1970, we were only dealing with interictal activity because that's all we could record. But with the ability to prolong the recording with high-quality EEG, we were able to go after the actual spontaneous seizure and get a little bit closer to the origins of the epilepsy itself. So that helped diagnosis and helped surgical intervention. I guess the other thing that came in there was also the MR and then the functional MR, and then the relationship of the functional MR bowl with EEG.
What are the 2 to 3 big issues in EEG that people are working on to solve today?
I guess they're still trying to get better EEG resolution and accuracy of detecting and indicating where the focus is, better detection systems and analysis of the spontaneous EEG and the epileptic aspect of the EEG, getting into seizure prediction, and then getting into even longer recording periods to get a better idea of the long-term effect of epilepsy.
What are the main areas of professional discussion or disagreement today?
Yeah, I'm not too sure where that is. I guess there's some significant controversy over the significance of the high-frequency EEG activity related to the seizure, and then the significance of positive or negative bold revealed during functional MR EEG. So I guess that's two issues. And whether predicting the EEG, predicting whether a seizure can be indicated in the future and how soon in the future, and whether that can actually be done or not.
What are you most proud of in your professional life?
Just contributing to the advancement of the field of EEG and the epilepsy diagnosis and treatment, and then more specifically ambulatory EEG and the synoidal electrode and digital computer long-term monitoring of the EEG, and then ambulatory home computer with video, functional MR EEG, and then imaging compatible EEGs for continuous EEG recording in the ICU. Just making, engineering contributions to the field.
Where do you see neurodiagnostics in 10 years?
I think they're going to get even smaller recording systems, smarter software, and improved analysis. They may be able to get it actually implanted in the under the skull, and then better electrodes, and the possibility of the area of bold and functional MR EEG is still evolving, so there may be some breakthroughs in that area, further breakthroughs in that area.
What is the best piece of advice that you ever received?
I guess, well, one of them was from Dr. Gluer, who basically said, never mind getting a PhD, just carry on doing what you're doing, because that's working out very well. I guess the other was from Dr. Rasmussen, and they said, always stay with the university. He's never seen a university go bankrupt, and just stay away from industry because you get bogged down in short-term goals, and it's an iffy situation employment-wise.
Is there anyone else in EEG you think we should talk to, or prominent electroencephalographers?
Jean Gottman, Fred Annerman, and Andre Olivier, to name a few, I guess.
Fred Adderman, is that?
Oh, Anderman. Fred Anderman.
Okay, and I have talked with Dr. Gottman, and I'm going to interview him in a couple weeks because he's out of town now at the Canadian Tech meeting, and that I'll be out next week, so that'll be good. He has agreed.
Okay, that's good.
And who was the other interview?
Fred Anderman is at the M&I, so
okay.
I'll put you in contact with him. And so is Andre Olivier at the M&I.
Okay. Yeah, because that's a place just so much was happening up there with all of you that was just amazing.
Yeah, it was a nice concentrated effort. It was a very small institute, actually. It's only 125 beds, but lots of things happened there.
And it seems like, like how you're talking about how you made the amplifiers small enough to go on the head, that you were doing that at a time when people, the electronics weren't really that small yet, or you didn't think it anyway, myself as a,
Yeah, because, well, the Model 8 with the modules that plugged in and out, and they were large.
Yeah, that's what I trained on. Yeah, I mean, they were huge, and things, and yeah.
Well, that was interesting. But that was, taking advantage of the development in the electronics industry. One of the first ambulatory systems we used was a Sony Walkman. So that was.
Oh, well, that's interesting.
Just rather around, we just turned it into an EEG machine. So.
That's really, yeah. Well, great. Yeah, I remember, when that was all coming out. It was like, look at this, It was so good.
Well, it was fun, too.
Yeah, I bet. You've done it, like you said, you have, used your engineering skills to really help make our job as technologists and then goes to the patients. Just learn so much. So thank you for all of that, really.
Well, I've always worked with EG technologists, too, because that's where the rubber hits the road, actually, where you make it happen. So,
mm-hmm.
And that's always been a pleasure.
Well, good.
Because
well, thank you.
Doctors really in the background. They read the records after you get them, so you have to get a good record before they can make a good reading. So counts on technology and technologists make that happen.
That's so true. Well, thank you, John. It's great to talk to you.
Okay, sounds good.
And take care, and I hope you feel better.
All right, thanks very much. And enjoy your reunion next week.
Oh, thank you. Well, see you in St. Paul, I would imagine, right, at the ASEC conference?
Yes, either I'm going to go or Patrick's going to go.
Okay.
So we'll see you. That's in August, I guess, huh?
Correct, right, the very beginning of August.
Yeah.
Okay, thanks again, John.
I look forward to seeing you again, Lucy.
Yeah, you too.
Bye-bye.
Bye-bye.